Time for passage number 3 from test 3. This passage is adapted from Thor Hansen. Feathers. Scientists have long debated how the ancestors of birds evolved the ability to fly. The ground-up theory assumes they were fleet-footed ground dwellers that captured prey by leaping and flapping their upper limbs. The tree-down theory assumes they were tree climbers that leapt and glided among the branches. Okay, which choice best reflects the overall sequence of events in the passage? We will skip that. As used in line 7, challenged most nearly means what? So here is challenged. So let's read our first paragraph. At field sites around the world, Ken Dial saw a pattern in how young pheasants, quail, tinamous, and other ground birds ran along behind their parents. They jumped up like popcorn, he said, describing how they would flap their half-formed wings and take short hops into the air. So when a group of graduate students challenged him to come up with new data on the age-old ground-up tree-down debate, he designed a project to see what clues might lie in how baby game birds learn to fly. All right, so challenged him. So not requested him, but wanted to know if he would do it, or wanted to know if he could do it. Right, put him to the test. So let's see. They dared him. That kind of fits with put him to the test, right? Challenge. They dared him to do something. They challenged him to come up with this data, dared him to come up with the data. Required him to come up with the data. It's unlikely that his students are going to require him to do anything. Also doesn't really fit with what we said here. Disputed with. They're not disputing with him. They want to see if he can do it. Competed with him. There's no indication that the graduate students themselves are coming up with the data as well. So we'll go with A. Which statement best captures Ken Dial's central assumption in setting up his research? It's a two-part question. We know this is between 1 and 24. Still not there yet, so let's skip it. This looks good. In the second paragraph, the incident involving the local rancher mainly serves to what? So let's see what's going on in the second paragraph. Ken settled on the chukar partridge as a model species, but he might not have made his discovery without a key piece of advice from the local rancher in Montana who was supplying him with birds. When the cowboy stopped by to see how things were going, Ken showed him his nice, tidy laboratory setup and explained how the birds' first hops and flights would be measured. The rancher was incredulous. He took one look and said, in pretty colorful language, "What are those birds doing on the ground? They hate to be on the ground. Give them something to climb on." At first it seemed unnatural. Ground birds don't like the ground. But as he thought about it, Ken realized that all the species he'd watched in the wild preferred to rest on ledges, low branches, or other elevated perches where they were safe from predators. They really only used the ground for feeding and traveling, so he brought in some hay bales for the chukars to perch on, and then left his son in charge of feeding and data collection while he went away on a short work trip. So what does this incident serve to do? How does it function? Well, it seems to be revealing something to Ken Dial, who then has to change his experiment as a result. Right? So he kind of takes the advice of this rancher and modifies his experimental setup. Reveal Ken Dial's motivation for undertaking his project. There's no sense here that we're learning about his motivation. It's just talking about how he rethinks his experiment. Underscore certain differences between laboratory and field research. I mean, I think they did mention the laboratory. They get the laboratory set up. I mean, what's tricky about this one is, in some sense, it's the difference being shown between the laboratory experiment he was doing and the way birds actually operate in the real world. So it's not really field research. It's, if anything, underscore certain differences between laboratory research and field behavior, maybe, but it's not about two different kinds of research. So this is, you might want to leave it if you're a little unsure. I'm pretty confident that B isn't the answer. It's not quite precise to what we saw here. Show how an unanticipated piece of information influenced Ken Dial's research. Yeah, that's very clear. Much more specific with what's going on here, right? He learned this fact about how the birds operate in real life and used it to change his experiment. Introduce a key contributor to the tree down theory. This cowboy, this rancher, doesn't look like he's going to be a key contributor. You can come back to it later just to make sure, but doesn't seem like it makes sense. The point, as we discussed, is that he got this piece of info, changed his research as a result, so we like C. We've already went through 1 through 24. What was the assumption? let's see. Maybe it goes back to here, right? His assumption was that if they're ground birds, that they like being on the ground rather than being on ledges. Maybe something like that. Let's see. The acquisition of flight in young birds sheds light on the acquisition of flight in their evolutionary ancestors. We'll come back to this one. Let's just read the rest. The tendency of certain young birds to jump erratically is a somewhat recent evolved behavior. It doesn't really say that or imply that. If anything, just the opposite, right? Because this is talking about how birds evolve the ability to fly and kind of from their older ancestors. So this doesn't really capture it very well, right? This is the problem, a somewhat recent. If you got rid of those choices and you had this, then it would work, perhaps, but it doesn't make sense with the somewhat recent. Young birds in a controlled research setting are less likely than birds in the wild to require perches when at rest. This is going to what's going on in that second paragraph, but that wasn't his assumption. He didn't even know that they would prefer perches until he was told that they would. Grounds dwelling and tree climbing predecessors to birds evolved in parallel. Doesn't mention or imply that anywhere. So I like A. And why do I like A? The whole point of the study that he's doing is to get new data on the age-old ground-up, tree-down debate, which was all about how birds or the ancestors of birds evolved the ability to fly. So if he's studying modern-day baby birds, he is assuming that the data he gets from that will shed light on the ultimate question, which is how birds evolved the ability to fly at all. So this is why it makes sense. This is the assumption underlying his experiment. So you have to do a little bit of reading between the lines, a little bit of connecting between the dots, but it's only one step beyond what's going on in the passage. And we'll talk more about this in the inference questions video coming up in a little bit. Which choice provides the best evidence for the answer to the previous question? I'm thinking it's right here, right? This is 8 to 9, or maybe 6 to 11. Let's see, 1 to 4. 1 to 4 just says he saw a pattern in how they hopped around. Doesn't say anything about this assumption. 6 to 11 looks pretty good, right? In the sense that he's going to get new data on this debate, and he's going to do so by getting info on how baby birds learn to fly. So B looks good. 16 to 19 just talks about this laboratory setup. 23 to 24 doesn't talk about anything, just talks about how the ground birds maybe want to be on the ground. Point is, B fits best with the overall assumption of the study. After Ken Dial had his aha moment, he what? So let's go to line 41. This might be a bit general because perhaps this goes on a little bit after, but let's just read up to it and see what we've got. Barely a teenager at the time, young Terry Dial was visibly upset when his father got back. I asked him how it went, Ken recalled, and he said, "Terrible, the birds are cheating. Instead of flying up to their perches, the baby chukars were using their legs. Time and again, Terry had watched them run right up the side of a bay hill, flapping all the while. Ken dashed out to see for himself, and that was the aha moment. The birds were using their wings and legs cooperatively, he told me, and that single observation opened up a world of possibilities." So just from what we have so far, after the aha moment, he realized that there were many different ways to go. So let's see if that's the answer. These look quite specific, so I think we're going to have to keep reading. So let's read through the next paragraph. Working together with Terry, who has since gone on to study animal locomotion, Ken came up with a series of ingenious experiments, filming the birds as they raced up textured ramps tilted at increasing angles. As the incline increased, the partridges began to flap, but they angled their wings differently from birds in flight. They aimed their flapping down and backward, using the force not for lift, but to keep their feet firmly pressed against the ramp. It's like the spoiler on the back of a race car, he explained, which is a very apt analogy. In Formula One racing, spoilers are the big aerodynamic fins that push the cars downward as they speed along, increasing traction and handling. The birds were doing the very same thing with their wings to help them scramble up otherwise impossible slopes. So what do we learn here? It looks like he goes on to do different experiments, videotaping the ways the birds run up these ramps to see how they use their wings and their feet together. Tried to train the birds to fly to their perches, does not mention that. Studied videos to determine why the birds no longer hopped. Be very careful. Half right, all wrong type trap. He did study videos to determine why the birds but then this falls up. No longer hopped. It's not about how they no longer hopped. It's about how they ran up the inclines, which looks good with C, right? Observed how the birds dealt with gradually steeper inclines. Notice that's exactly what it says right here. Consulted with other researchers who had studied Shukar partridges. Doesn't specifically say that. Nothing tells us anything that would make us infer that. So we will go with choice C. The passage identifies which of the following as a factor that facilitated the baby Chukar's traction on steep ramps. So we read this. It is the changing of the angles of their wings, and that's kind of allowed them to put force down to keep them attached to the surface. So the speed at which they climbed, not mentioned. The position of their flapping wings, yeah. The alternation of wing and foot movement, doesn't mention that, hasn't mentioned it yet, and likely won't. Their continual hopping motions, mentioned elsewhere but not in this portion of the passage so that we're looking at specifically. So we're going to go with B, right? The position or the angle, right? How they held their wings. In 61, document most nearly means what? So here's document. Ken called the technique WAIR for wing-assisted incline running and went on to document it in a wide range of species. So maybe something like observe or identify or record, something like that. Portray? No, he's not portraying it. He is indeed recording it, right? He is taking down the data. He's observing it. So record looks good. Publish, maybe he did publish, but that's not what document means in this context. Same thing with process. He might have processed the data, but really in this context, it's about how he recorded it or observed it. What can be reasonably inferred about gliding animals from the passage? So that's an infer question. Let's finish the passage and then maybe we'll try that one. It not only allowed young birds to climb vertical surfaces within the first few weeks of life, but also gave adults an energy-efficient alternative to flying. In the Chukar experiments, adults regularly used WAIR to ascend ramps steeper than 90 degrees, essentially running up the wall and onto the ceiling. In an evolutionary context, WAIR takes on surprising explanatory powers. With one fell swoop, the dials came up with a viable origin for the flapping flight stroke of birds, something gliding animals don't do, and thus a shortcoming of the tree-down theory, and an aerodynamic function for half-formed wings, one of the main drawbacks to the ground-up hypothesis. So we want to know what can be inferred about gliding animals. So what can be inferred, it looks like, is that they don't flap their wings. It's a bit hard sometimes to come up with your own answer to infer questions, but let's just see what else we know about the gliding animals. These are the tree down theory, right? Tree down theory assumes they were tree climbers that leapt and glided. These are the ground birds that take the hops. Let's go to the choices and just see what we've got. Their young tend to hop along beside their parents instead of flying beside them. This, I think, applies more to the ground birds, which is the whole point. The ground birds are the ones that hop, I believe. Let's just double check on that. Yeah, ground birds are the ones that ran along behind their parents. They jumped up like popcorn, so this does not apply to the gliding ones, so we can get rid of A. Their method of locomotion is similar to that of ground birds. That doesn't seem like that would make any sense because the point is that they're different, right? One glides, one hops or bounces. They use the ground for feeding more often than for perching. Doesn't seem like they mention anything about that, about whether they use the ground for feeding. Specifically with the gliding birds, they do not use a flapping stroke to aid in climbing slopes. So here is, I think, the key. The whole point of this is they're looking at these ground birds and how these ground birds used their wings to walk across the ground. This does not apply to the gliding birds, right? This is about the ground. This is about, or this part, using the flapping stroke. This is what the ground birds do, not the gliding birds. And the whole point, which we can see here, is that this theory explains the flapping flight stroke of birds, something gliding animals don't do, right? So if the gliding animals don't do the flapping, they don't do the hopping or the bouncing or the flapping stroke, basically. because that's something that the ground birds do. So D looks good. And in fact, I think these lines looks like 72 to 74 fit, and that's good. We got D. Let's just check the rest. 4 to 6. We're looking for information about the gliding birds. 4 to 6 has to do with the hopping ground birds. We'll get rid of that. 28 to 29. Here they mentioned the feeding thing, but this is again about the ground birds, how they used their ledges in the wild, or at least how Dial thought they used ledges in the wild, not about the gliders. 57 to 59. Again, about the ground birds, not about the gliders, so D is our answer. All right, let's now go back to the opener. Which choice best reflects the overall sequence of events in the passage? So, looks like it begins with a problem. They find a surprising result, and then they go on to connect that result to a bigger theory. Something like that. An experiment is proposed but proves unworkable. That doesn't quite work. A less ambitious experiment is attempted, and it yields data that gives rise to a new set of questions. This less ambitious thing doesn't really make sense. I mean, the rest of it's good, but those single words are enough to get rid of A. A new discovery leads to reconsideration of a theory. A classic study is adapted and the results are summarized. I don't think a classic study was adapted here. The whole point is the study that he did was new, like filming the birds walking up these inclines. So we can get rid of B. An anomaly is observed and simulated experimentally. The results are compared with previous findings, and a novel hypothesis is proposed. So the anomaly was the son, Terry, seeing that the birds were cheating. That's the anomaly. It was simulated, I guess, by making the birds walk up ledges, I guess. And the results are compared to previous findings. Maybe that's this portion, right, about how it compares to the hopping. And a novel hypothesis is proposed. Yeah, it's this hypothesis about how this might be an explanation for where flight came from. So, C might work. An unexpected finding arises during the early phase of a study. That seems pretty good. The study is modified in response to this finding. Also seems pretty good. And the results are interpreted and evaluated. That seems pretty good too. So both C and D seem solid. So now we have to go to the choices more closely and really expand on them. And my first thought is that D is better because it's more general. And generally speaking, general answers are going to be better on the reading than specific ones. So I do like D for that reason. It fits all the pieces that we discussed. Let's just look at C and try to maybe reevaluate it and see maybe where C doesn't work. I mean, the novel hypothesis does work. I guess the issue I was running into is there's no real specific comparison with previous findings. I think I hand-waved that a little bit when I was analyzing the passage before, but I don't actually think that works. The anomaly works. Maybe the simulated bit doesn't work either on second thought. They're not really simulating it. They're more like testing it. A little bit weak. I think there are some weaknesses to C, which is why ultimately we go with D. All right, and that should be it for this passage. Let's move on to passage 4.